They call me the Michael Jordan of SAT Math, the Da Vinci of SAT Math, the Hans Zimmer of SAT Math. And in this video, I'm going to show you plebeians how it's done by taking Bluebook Practice Test 6. And my goal is not just to tell you the correct process, it's to show you how to identify the correct process on your own. So sit back, relax, grab a snack, and let's absolutely obliterate this practice test. Question number 1. If you get this one wrong, David Coleman will personally come to your house and beat you up. So you really need to make sure you got this one on lock. A certain bird species can fly at an average speed of 16 meters per second in continuous flight. At this rate, how many meters would the bird species travel in 4 seconds? So a lot of people are going to get this very intuitively. You go 16 meters a second for 4 seconds, that's going to be 64 meters. But let's sort of break down why this is the case so you can really feel good about yourself. This is a linear function between seconds and meters. Basically, as we go 0 seconds, we travel 0 meters, 1 second, that's 16 meters, 2, we go 32, etc. And so if we call seconds x and meters f of x, we see that 16 meters per second is really saying 16 f of x per x. In other words, 16 is your change in y over your change in x, which is the same as the slope. So we could write this linear function as f of x equals 16x. And what we're solving for is the amount of meters, so we're solving for f of x when x equals 4. When your seconds equals 4, that would be f of 4, that's 16 times 4, that's 64. And so you're not actually going to be writing this all out on the SAT. I just think it's incredibly helpful to be able to break down a scenario like this, identify it's a linear function, identify that 16 is your slope / your rate of change, and then being able to set up the equation if you had to do that instead. But this specific problem should take you like 5 seconds. Okay, pause. If you like my style of teaching and you're trying to get a perfect or near perfect score on the SAT Math, you should check out my SAT Math Masterclass. This class is meant for tryhards, okay? Most students that go through this class end with a 750 or higher. That is not easy for most people to do. This is not some pre-recorded course that you have to self-study. These are live sessions with a couple of students and myself where we walk through all of the hardest content on the SAT Math. It's super laid back, it's fun. Guys, what are we doing? Students compete for money like Squid Game. Spots are limited, but I run these classes multiple times a year, so go over to learnsatmath.com and see if there's a spot available. Okay, back to the video. Number 2, line R in the xy plane has a slope of 4 and passes through the point 0, 6. If we pass through the point 0, 6, that means the 6 is our y-intercept, because the y-intercept is basically the y value when your x is equal to 0. And so using y equals mx plus b form, we know that the slope has to be 4 and the y-intercept has to be 6, so our answer choice is going to be D. Number 3, which expression is equivalent to this? This type of problem is called an equivalent expressions problem. You know it's an equivalent expressions problem because they will tell you which expression is equivalent to this. These problems are testing your algebra skills. It's testing, can you go from point A to point B algebraically. Point B is not necessarily going to be simplest form. It's just some arbitrary starting point and some arbitrary endpoint, and you have to convert one into the other algebraically. So one approach that a lot of people take is they put the starting point into Desmos, and then they put all the answer choices into Desmos and see which answer choice has the same graph as the starting point. The problem with this is it can be a little time consuming, and you also want to be more comfortable with algebra. Like if you can't solve this problem by hand, it doesn't bode well for you for the SAT. So Desmos can be a crutch. I would still recommend you try to solve this by hand. And the way to solve this by hand is to think to yourself, what is different about your answer choices than your starting point? The clear answer is all of your answer choices have factored something out. So your first thought should be, how do I factor something out of this expression? The greatest common factor is x cubed, so chances are we're factoring out an x cubed, and that alone should be enough to be able to pick your answer. But let's imagine that this 8x cubed were just a regular x cubed and we still had to distinguish between the thing in parentheses. We would factor out the x cubed and we would get 5x squared minus 6x plus 8. And that would be answer choice B. Number 4, the equation x plus y equals 1440 represents the minutes of daylight, x, and number of minutes of non-daylight, or nightlight. That nightlight sounds wrong, but we're going to call it nightlight because it's funny. If this day has 670 minutes of daylight, so 670x, then how many minutes of non-daylight does it have? So what is y? You want to think about translating your English into math, and what this means for a problem like this is translating the word daylight into the variable x. So that when you read 670 minutes of daylight, you immediately identify that that means x equals 670. And when you're asked to solve for minutes of non-daylight, you immediately realize you're solving for y. So then we take this equation, we say 670 plus y equals 1440. And when we solve for y, we get y equals 770. Problem number 5, Scott selected 20 employees at random from all 400 employees at the company. So just by reading that sentence, I immediately know what type of problem it is. It's a sample population problem, where our population is 400 employees at the company, and we're taking a sample of 20 employees. And the motivation behind sample and population problems is that we don't want to ask all 400 employees, have you enrolled in a professional development course, because that would be time consuming. We're only going to ask 20 of them, and then we're going to extrapolate their findings to the entire population, because chances are if we sample those 20 people randomly, they're going to be pretty representative of the entire company, right? So if half of them were in the professional development courses, then we would say probably about half the company would be, as long as we're randomly sampling these 20 people. And indeed, we are. He found that 16 of the employees in the sample are enrolled in 3 professional development courses. Okay, so 16 out of the 20 were enrolled in 3 professional development courses. Which of the following is the best estimate of the employees at the entire company who are in these 3? So just as I said before, whatever percentage or rate that we have for the sample, we can extrapolate that to the population. So 16 out of 20, we can extrapolate that to the population by saying 16 out of 20 times 400 gives us the amount of people that are enrolled in 3 professional development courses. If you put that into your calculator, you should get 320. You can also convert this into a percentage if that makes more sense to you, to think about this as 80% of your sample is in those courses. And so we want 80% of 400. Question 6 asks which equation has the same solution as the given equation. So when we're trying to find solutions, you can always put this into Desmos. If we put this verbatim into Desmos, it would give us a vertical line, and that would be your x value. And then you could sort of use that x value to figure out which of these equations has to be true. But we're going to solve this a little more directly. All of the answer choices have 2x minus something. So let's see if we can rearrange this equation to solve for 2x minus something rather than solving for x. So the easiest thing is if we divide both sides by 7, if we divide this by 7, and we divide that by 7, we should get 2x minus 3 equals 9. And just like that, we've solved the equation. So College Board likes to do this sometimes. They sort of give you hints that a problem can be solved a certain way. In this case, the hint is all the answer choices have 2x minus something. This is the same thing as if they give you something like x plus y equals 10, and they're like, what is 2x plus 2y? It's 20, right? Don't need to solve separately. You can solve directly for the combined expression. Problem number 7, the given equation relates CP and K. Which equation expresses C in terms of P and K? So when they say C in terms of P and K, that means we want a C equals something something P something something K expression, right? Like we want C isolated on its own side of the equation, and then everything on the other side is P's and K's. And that's pretty evident from the answer choices as well. So this is just a question of isolating C. And there's only one step we need to do to isolate C, which is add 7 to the right, add 7 to the left. C equals 25P plus K plus 7. It's as simple as that. Question number 8, it seems from our answer choices we're dealing with exponential growth. So a function P estimates there were 2,000 animals in 1998. Each year from 1998 to 2010, we increased the number of animals by 3% of the previous year. Which equation defines this function where P of X is the number of animals in the population X years after 1998? So X years after 1998 means that when X is 0, that's the same as the year 1998, right? And we're told that in the year 1998, there were 2,000 animals. So when X is 0, P of X is 2,000. And we can already tell that that's pretty evident from these answer choices, because if we plugged in x equals 0 into any of these answer choices, you would get 2,000. That's because 2,000 times 3 to the 0, well, anything to the 0 is 1, so that's 2,000. 2,000 times 1.97 to the 0, also 2,000. So this alone does not tell us enough. We need to also consider the growth rate. So we're told that the population increases by 3% of the previous year. This means that after 1 year, we have 2,000 times 1.03, because when you multiply something by 1.03, that is a 3% increase. You can think of this growth rate as 1 plus r, where r is your rate of growth as a decimal. So in this case, 3% as a decimal is 0.03, and so that would be your R. 1 plus 0.03, well, that gives you 1.03. Be very comfortable with percentages as sort of a prerequisite to being able to approach these exponential functions problems. So we know that every single time our x increases, we multiply by another 1.03. So we're sort of chaining these 1.03s together. And therefore, a more concise way of writing this would be 2000 times 1.03 to the x, which is answer choice C. Realistically, on the SAT, you should not be going through all these steps. You should see the 3% and immediately go to 1.03. And so this problem really shouldn't take long, but in order to build that understanding of exponential functions, you need to understand sort of where it comes from. Number 9, we have another equivalent expressions problem. It asks which expression is equivalent to this. So once again, we have a starting point and we have some endpoints. What's different about the endpoint from the starting points? Well, there are only 3 terms. And so we need to somehow convert this into that by maybe expanding it out and then combining like terms. So let's do exactly that. If we square this, think about using FOIL. Our first 2 terms is x to the 4th. Our outer terms would be 11x squared, inner terms 11x squared, last terms 121. And then same thing here, we're going to use FOIL again. This one is a difference of squares. So technically what this is x squared minus 5x plus 5x minus 25. But these 5x's are going to cancel out, right? 5x minus 5x, that's 0. So really this is just x squared minus 25. And I did that so quickly in my head because I acknowledge that this is a difference of squares. Basically, when you have one term times another term, where one of them is x plus something and the other is x minus that same thing, it's a difference of squares, where you know that your inner and your outer terms are going to cancel out. And so now it's a question of combining like terms. So we have x to the 4th, then we have to combine all the x squareds together, we get 23x squared, and then we have to combine our constant terms together, we get 96. If you don't trust yourself to do this math in your head, use a calculator, right? Don't be afraid to use a calculator. It's better to use a calculator than to get it wrong. I personally use a TI-84 for arithmetic just because I feel like I'm faster with the buttons. But you can also use Desmos. Like if you're not entirely sure what 11 squared is, just do 11 up caret 2. Number 10, we're chucking an egg off a rooftop. This equation represents the situation where h is the height of the egg above the ground and t is seconds after it's thrown. According to the equation, what is the height? So what is the h? What is the y? From which the egg was thrown. Well, from which the egg was thrown, what does that mean mathematically? Well, if we're throwing the egg, if t is the seconds after we're throwing the egg, then when we throw the egg, that is t equals 0. So this is basically saying, think of this as a function h of t. We're solving for h of 0. One approach that you could take is you could plug in 0 and solve. Another approach is h of 0 is just the y-intercept, so we can use Desmos for this. We can type in negative 4.9 times x squared plus 9x plus 18 into Desmos, and this will give us our function for h, and we simply select the y-intercept, and that's the correct answer. In this case, it's 18. Another thing you could do is you could turn this into a function, say h of x equals this quadratic, and we want the y-intercept, so sure, you can click on this, but if we're too lazy to do that, you could just type in h of 0 equals 18. This isn't necessarily faster, it's just an alternate way of getting the same answer, and I want to show that this is a thing that you can do. However, both of these are suboptimal. The fastest way of solving this is knowing that in a quadratic, your c term or your constant is the y-intercept. So we can simply look at this function, and as long as we realize that we're solving for the y-intercept, 18 is our answer. And if you're wondering, well, why is 18 the y-intercept, just by looking at the function, think about what happens if we plug in 0 for t. Negative 4.9 times 0 squared plus 9 times 0 plus 18. And this is 0, that's 0. H of 0 is 18. Ideally, have it memorized that when you have a quadratic in standard form, your c term is just your y-intercept. Number 11, if 4 rad 2x equals 16, what's the value of 6x? So one approach is we can solve this with Desmos directly for x, and then we just multiply by 6. So 4 times the square root, I'm going to type sqrt for square root, 2x equals 16. However, there's a problem with this. this vertical line is not clickable. There's no visible x-intercept. So what we can do to solve this is a very easy fix. We simply do y equals, and then the left-hand side of the equation, so for sqrt 2x, and then y equals the right side of the equation, 16. And so basically what we're doing is we're breaking the single variable equation down into a system of equations. So this is one equation, this is another, and what we're concerned with is the point that they intersect. Notice this point is at the green vertical line. So we have 8, 16. We are concerned with solving for x, so we're concerned with 8. And so that would be the correct answer. For x, we're solving for 6x. So we don't just want 8, we want 8 times 6. 48. If you wanted to do this by hand, it would probably be about equally as fast. So I'm going to go over both approaches. If we have 4 times the square root of 2x equals 16, we want to isolate 6x is really how we should think about it. But the big problem is that our x's are under a radical and we don't want them to be. So what we can do, whenever you have a radical you're trying to get rid of, you can square both sides. When you square two terms multiplied together, you can think about that as like distributing the two. The way you should understand this is imagine you had 2 times 3 squared, right? This is the same as 2 times 3 multiplied by itself. So another 2 times 3. So if we want to get that result, 2 times 3 times 2 times 3, you can think of distributing the 2. But if you square the 2, that doesn't help you get the second 3. You also need to square the 3. So the square has to be applied to the 2 and the 3 because we need 2 of each term within the parentheses. That's how you should think about it. Because this confuses people of like why we don't just say that 16 rad 2x, but rather 16 times 2x. And then here we have 16 squared. I can divide both sides by 16 to get 2x equals 16. And then instead of solving for x and then multiplying by 6, I can get from 2x to 6x by multiplying both sides by 3. Probably about the same amount of time as if you use Desmos, although Desmos is typically more reliable. Number 12, the relationship between two variables x and y is linear. Cool. For every increase in the x by 1, the value of y increases by 8. So immediately, you should be able to clock this as the slope. This is telling you that the slope is 8. If you don't immediately clock this, let's think about it. So the change in x by 1 increases the y by 8. That means we go up 8. We go 1 to the right, we go up 8. This is the slope, right? The slope is the change in y over the change in x. So if our y going up by 8 means our x goes up by 1, that means that the slope is 8 over 1, which is 8. So let's continue now that we've identified that the slope is equal to 8. When the value of x is 2, the value of y is 18. Which equation expresses this relationship? So when in doubt, set up a table. So we have our x's, we have our y's, and we know that when x is 2, y is 18, and we know that the slope is 8. So the slope being 8 should already tell us that the answer choice is C. But let's think about this a little more. Imagine D were 8x plus 4. It's like, how would we know that the answer is C and not D? We can be super formulaic about this. Set up y equals 8x plus b, and then plug in this point to solve for b. We get b equals 2. Alternatively, you can think, you can sort of use the table and like go backwards. So if the slope is 8, that means that when x is 1, we should be 18 minus 8. When x is 0, we should be 10 minus 8, so that's 2. This is a little less reliable. Like imagine if x were 200, you wouldn't want to go back 200 points. It's also like you can totally make errors doing this. You might add 8 instead of subtracting 8. So this is probably the approach that you'll want to take when figuring out the y-intercept, but this is certainly something that you can do. Number 13, how many distinct real solutions does this given equation have? So a real solution just means like non-imaginary solution. So like the square root of -10, that would be imaginary. We're excluding that. Real numbers can be anything from 1 to 15 to pi. Real numbers are just like what you think of as numbers. You know what? Negative pi, screw it. So don't be intimidated by the term distinct real. Just think of this as how many solutions does the given equation have. So hopefully you're able to look at this and be like, oh, well, something definitely doesn't seem right because we're squaring something and getting a negative number. What number squared gives you a negative number? It's not a positive number, right? 10 squared is positive 100. But it's also not a negative number, right? Negative 10 squared is also positive 100. So the answer is there are no real numbers that we can square and get a negative number, which means we can immediately pick 0 real solutions to this equation. But if you don't immediately make that observation, you can also solve this with Desmos. We can put the equation into Desmos and we see Absolutely nothing, right? And this can be a little intimidating because it's like, maybe the solution is there. We're just not scrolling far enough. But like, there's no solution. Desmos sort of confirms this for us. Ideally, you should understand why that's the case, not just because Desmos said so. Problem number 14 uses box plots. This is sort of like you either know it or you don't. It tells you for a given data set, like class A's books, what the minimum is, that's this line, what the maximum is, that's this line, and this middle line, what the median is. To be more specific, it also tells you the 25th and 75th percentile. Like really, you can think of this as 0th percentile, 25th percentile, 50th, 75th, and 100th percentile. For the SAT, it almost always only concerns you with the minimum, that's this, the maximum, and the median. Not the mean, the median. That's important. So we're asked, what's the positive difference between the ranges of number of books read over the summer for the two classes? So the range of a data set is just the maximum value minus the minimum value. So we want the range of class A, that's 5 minus 0, so 5. And we want the range of class B, that's 10 minus 1, which is 9. And so your answer is the difference between the ranges. Difference, the word difference always indicates subtraction, so we can think of this as 9 minus 5, which is 4. The length of the edge of the base of a right square prism is 6 units. What does that mean? That's a lot of ofs in the same sentence. Well, wow, that's a terrible joke. You know what? We're just going with it. We have a stick of butter, basically. We have a vertical stick of butter. We've got a square base, which means the edges are the same. And we're told that the edge of the base is 6 units, so that's this and this. These are both 6. And we know that the volume of a right square prism is the length times the width times the height. It's on your formula sheet if you forget. But in this case, the length and the width are the same. So we can just think of this as 6 times 6, or 36. Since we're told the volume is 2880, we get this equation, and we're asked to solve for the height. So that's just solving for h. We do 2880 divided by 36, which presumably is 80. Problem number 16, the scatter plot shows the relationship between two variables, x and y. Yeah, of course. An equation for the exponential model can be written like this. Yeah, of course. Which is the closest to the value of b? So if you understand exponential functions well, as we've briefly talked about before, you can think about b as the growth rate. A is sort of what we're starting with. So like when x is 0, y is equal to a, right? Because a times b to the 0 is a times 1, which is a. And then every single time x increases, we're multiplying by another b, right? So think of this as ab, then abb, then abbb, etc. Unlike linear functions where we add our growth rate, that's the slope, where if our slope is 2, that means every time our x goes up by 1, like 0, 1, 2, 3, our y goes up by 2. Here, we're multiplying the growth rate. So in an exponential function, if you have a growth rate of 2, that means you're doubling. And so if we look at our answer choices, only one of these really makes sense, because think about what's happening every single time we increase x by 1. Our y is decreasing, right? This is not exponential growth, this is exponential decay. We're getting exponentially lower over time. And so the only way to multiply by a number over and over and have your entire product get lower and lower is if that number is a fraction, like 0.83. 0.83 in particular means we are decreasing by 17%. Think of taking A and multiplying it by 83%. That leaves you with 83% of A, which means you've shaved off 17% of A. All these other answer choices are increasing the value of A. Their graphs should look like that. Let's imagine a scenario where the other answer choices were also fractions, like 0.9, 0.7, 0.5. How would you be able to solve this? Well, what we can do is we can run a regression. So a regression basically just means we're fitting a curve or a line to a bunch of points. So we'll see what this looks like in a second. I can go into Desmos, and I can click on this plus button and add a table. And then within the table, I can put some of these points. Now, we're not given the points exactly, but we're given kind of the points. I can pick this point. This point looks like roughly 1, 110. Not exact, but it's okay for this purpose. And then down here, on the most other extreme end, we have the point, let's say 11.5 and maybe like 15. again, rough estimates, that's fine. We'll see why in a second. We plot these points in the table, and then we can click Add Regression. A linear regression tries to fit a line through these 2 points. And it can do that, but that's not what we're concerned with. We want a curve, we want an exponential function to go between these points. So you can click on this drop-down menu and go down to exponential regression. And from here, we see it creates an exponential function. It is 1.32, or 132, sorry. That's like your A times 0.827, that's your B to the X. 0.827, that's very close to 0.83. And because our points are rough estimates, they're not exactly on the line, we are only going for an approximation. We're not going for the actual value because we don't know the actual value. And so we can concretely say 0.83 is correct. One other thing to mention before we move on is the 2 points that I picked were the farthest points apart from each other. And this is very, very important if you're trying to create a line of best fit, or in this case, a curve of best fit, because the farther the points are, the more the curve is going to approximate the actual curve. Imagine I picked this point instead, we might get an exponential curve that looks more like this, which you'll notice is farther from the reality, and especially at farther out intervals, you might see is completely different from the reality. But again, this problem is solvable just by acknowledging that 0.83 is the only one that's less than 1 in this problem. Okay, this problem is laughably easy compared to everything else we've been doing. The cosine, you should just memorize SOHCAHTOA, where the cosine is your adjacent side over your hypotenuse. So the adjacent side to x is this 11, and the hypotenuse is 28. So the answer is 11 over 28. When you answer fractions on the SAT, you need to be very deliberate that you're answering in simplest form. So if we found that this was 22, and this was 56, for example, we would need to make sure that we're putting 11 over 28 in our answer choice. The SAT would not accept 22 over 56. Question 18, what is a positive solution to the given equation? The reason the SAT specifies positive solution is because there are multiple solutions to this equation, and we're only supposed to pick the positive one. The way we should think about this is these are 3 numbers multiplied together. The only way for 3 numbers multiplied together to give us 0 is if one of those numbers is 0. So this could be 0 times we don't care what the other 2 are. This could be 0 times we don't care what the other 2 are, or this could be 0. And so you can express this as 3 different equations. X plus 2 equals 0, x minus 5 equals 0, x plus 9 equals 0. But if you've done this enough, you sort of realize that, oh, it's just going to be the negative. So if this is positive 2, that's negative 2. It's positive 5, negative 9. Right? Like you can sort of do this step very quickly in your head without having to write everything out. And the only positive number is 5, so that's going to be our solution. Okay, now we're getting at the real problems. This is a real problem, number 19. W, Z, and X, Y intersect at point Q. YQ is 63, WQ is 70, WX is 60, and XQ is 120. So if you're doing this on the SAT, you can't write over the figure like I've done. You should literally redraw the figure and then label all the sides on your own. And the goal of this problem is to find the length of YZ over here. So when you're trying to find the missing side length, your instinct might be Pythagorean theorem. The problem with that, these are not right triangles, or at least they're not necessarily right triangles. Maybe A is a 9-degree angle, maybe it's not, we don't know. So we can't necessarily use the Pythagorean theorem here. The second option is similar triangles. But you might say the problem never tells us that these are similar triangles. How would we know if they're similar triangles? Well, we are told that this angle A is the exact same, and we know from our angle theorems that this angle and this angle have to be the same as well. If these 2 angles are the same, and these 2 angles are the same, then the third angles also have to be the same, because all the angles in a triangle have to sum to 180. So if these 2 angles plus this missing angle has to equal these 2 angles plus this missing angle, then the 2 missing angles have to have the same measurement. And so since both triangles have the same exact angle measurements, we can say that they're similar. And we can say that the sides are proportional based on where they are relative to their angles. So for example, the 70 is between the blue and the pink. So we could say that that is proportional to this 63. Likewise, this 60 is between the blue and the green, so we can say it's proportional to YZ. And then we can solve for YZ. And the way that you set up this ratio is really up to you. There are a lot of different ways you could set it up. You could also say, oh, well, we're trying to solve for YZ. YZ over 63. That's the ratio of the blue-green side to the blue-pink side. So we want the blue-green side, that's 60, over the blue-pink side in the same triangle. This ratio and this ratio are the same ratio, if you think about it. Like when we cross multiply, we're doing the same cross multiplication in both of these ratios, it doesn't matter how you set this up. I don't want to do all the cross multiplications. So I'm going to have Desmos do it for me. So we put the ratio into Desmos. I'm putting X instead of YZ so that Desmos actually knows how to handle it. And rutrow, we can't click on this vertical line. But the solution to this is pretty simple. All you got to do is take the left-hand side and make that a Y equals equation. So Y equals the left-hand side. And then you do a Y equals the right-hand side. And now we've converted the single variable equation into a system of equations, which means we have two equations. And what we care about is the point of intersection. And we see it's x equals 54. So sure enough, that is going to be the answer, 54. Question 20. The function g is defined by this and passes through this point. What is the value of g of 0? G of 0 is referring to the y-intercept. So basically this is saying we have this function g, we know it's a quadratic function because we have two x's multiplied together, and we're trying to find the y-intercept of this quadratic. And so the awkward thing is if we were to plug in g of 0, we would get 0 plus 14, that's 14, times t minus 0, that's t. But this isn't a concrete answer. We can't put 14t into the answer choice. We need to solve for this mystery constant t in order to get our answer. And so if you're stuck here, look at the remaining information that we're given. We're told that the function passes through the point 24, 0, which means if we plug in 0 for g of x and 24 for x, we should be able to get an entire equation where everything is known except for t. And then from here, we can solve for t. We get 38 times t minus 24. Since 38 times something equals 0, that means that that something, t minus 24, has to be equal to 0, and we can solve for t by adding 24 to the other side. Since t equals 24, we can say 14t is actually 14 times 24, and then we put that into our calculator and we should get 336. Problem number 21. This looks like a percentages problem. We have the number of zebras in a population in 2018. So let's call this Z 2018 for zebras. Was, so equals 1.27 times the number of zebras in 2014. If the number of zebras in this population in 2014, so Z 2014, is means equals p%. Whenever you have a percentage, you can do p over 100 to sort of convert this to a decimal. Because think about it, if you have like 40% of 10, that's not 40 times 10. It's 0.4 times 10. So p% of indicates multiplication, the number of zebras in 2018, so Z 2018. Because we are very slow and methodical, we set up these equations correct. It would be very easy to have accidentally made this 2018 and made this 2014. And then you would make the mistake of saying P is 27% or 127%. But we know that that's not the case because this is 2018 and this is 2014. So we can't just say that these coefficients are the same. Instead, what we can do is we can take one of the equations and put it into the same form or same structure as the other one so that we can very clearly compare the coefficients. So in this case, if we wanted to isolate z over 2018, we could multiply both sides by the reciprocal. So this leaves you with z 2018 equals 100 over p times z 2014. And so now we've got this equation and this equation, which are referring to the same thing. And so we can say that 100 over p equals 1.27 because these line up perfectly. You could also think of it as like we're substituting this into z 2018 over there. But that sort of overcomplicates things. I prefer thinking about it as like it's in the same form, so you can just like line up your slopes. So p would be 100 divided by 1.27. And we can put that into Desmos to solve. We get 78.74. We're asked to find the nearest whole number, so we would just say 79. Finally, we have a circle problem. So the equation of a circle is x minus h squared plus y minus k squared equals r squared. And I talk about this in more detail in this video. Hopefully I'll remember to include it. But the basis behind this formula is that we have a center of the circle and we have a point on the edge of the circle. And the line that connects these two is the radius. And so we can break this down into a horizontal distance of x minus h and a vertical distance of y minus k. Think about this like horizontal distance as like, imagine x were 5 and h were 2. Then the distance between these two x coordinates would be 3. So we have this right triangle that sort of connects these 2 points. And if we do the Pythagorean theorem on this right triangle, you get the circle formula. You get x minus h squared, that's like your a squared, plus y minus k squared, that's your b squared, equals r squared, that's your c squared. So the circle formula is literally just the Pythagorean theorem. And this is 100,000,000% something that you should memorize for the SAT. So they give us the formula for the circle. They also show it graphically, even though they don't need to for this problem. And they tell us circle B not shown is the result of shifting circle A down 6 units. So we're going down 6 and increasing the radius by 2x, right? So the radius here is 3. Now we want a radius of 6. Whee! So it's going to look something like that, right? And we're asked which equation defines circle B. So if we know the circle formula, well, we know the center has to be down here, right? This is 6 units down, aka the center should be at h of -2, k of -6. So x minus h squared, y minus k squared equals r squared is our formula. Should be x plus 2 squared plus y plus 6 squared equals r squared. So this alone should tell us it's presumably going to be answer choice A, but just to make sure that our r squared is good, our radius here in the first circle is 3, right? Because your r squared on the right side is 9. Square root of 9 is 3. So we want to double that. So now the radius should be 6 squared, which is 36. This doesn't tell us 36. It tells us 4 times 9. But that's the same thing, right? I don't know why they're doing that. Perhaps they want you to think about it as taking your radius squared. It's like 2 times your initial radius squared. Then that's like 2 squared times your radius squared, which in this case is 4 times 9. Maybe that's why they're doing it. But if you know this formula, you can solve this problem like 5 different ways. Even if they didn't give you this graph, this would be completely solvable. On to module 2. A manager is responsible for ordering supplies from a shaved ice shop. The shop's inventory starts with 4,500, so 4,500. And the manager estimates that 70 of these cups are used each day. So we use 70, which means we lose 70 per day. So we'll multiply by the number of days. Based on this estimate, in how many days will the supply of paper cups reach 1,700? So this is referring to the supply of paper cups, and we're trying to figure out what day this number equals 1,700. So this is the equation that we have, and this is just a question of solving for D. If you read this entire paragraph and have no idea what that corresponds to mathematically, when in doubt, set up a table. After 0 days, we have 4,500 cups. Then after the first day, we're using 70 of these. So we'll go down to 4,430. After another day, we go down another 70 cups, so 4,360. Hopefully by now you'll have realized the pattern. Oh, so every time our days increases by 1, our cups goes down by 70. That should indicate a slope of -70, where our y is our cups, and I'm going to keep d as days, would be -70, and then a y-intercept of 4,500. And since our y is cups, we're looking at when cups, so y, reaches 1,700. So therefore, your cup should be 1,700. So you can get to this equation just by like reading the question and having this be intuitive to you. Or when in doubt, create the table. And then your table should make it a little more revealing what your slope and your intercept are, because this is just a linear function at the end of the day. So now that we're here with our equation, no matter how we got there, we can go into Desmos and basically solve for what D has to be. We have 1,700 equals -70x plus 4,500. We're solving for this given x value, which is 40. Number 2, we have a triangle RST. Whenever we have some sort of figure, you should draw it out on paper, even though it's tedious. The measure of R is 60 degrees, which the following could be the measure of angle S. I'm going to call this X degrees. So the word could, when the SAT uses the word could, what could be the answer, what could be the measure, they're using it deliberately because there are multiple answers. Right? So we only know one of the angles in the triangle, which means we can't definitively solve for angle S. For all we know, angle S could be 100 degrees. It could also be 1 degree. We don't know. But what we do know is that angle X plus 63 plus whatever angle T is has to be equal to 180, which means angle X plus angle T has to be 117, which means since both of these have to be positive numbers, x has to be less than or equal to 117. In fact, sorry, it has to be strictly less than 117 because we can't have a 0 degree angle. We could, in theory, have a 0.000001 degree angle, but we can't have a 0 degree angle. Whenever you see the word could, it indicates some sort of inequality or some sort of range of values that all could be correct. And we're not solving for a definitive answer, we're solving for the only answer that makes sense given the inequality, which would be 116. All of the other answer choices, the angle would be way too big. question number 3, I've seen these questions approached a variety of different ways. I'm going to share what I personally think is the best way to approach this. So basically we have this inequality y is greater than 4x plus 8, which means we have some line 4x plus 8, and y can be anything above that line. And we're trying to find which table has all of its points above that line. So we want a table where all 3 points are like these 3 points. They're above the pink line within the shaded region. And so one thing that we could do is we could go into Desmos, we could graph the inequality as an inequality, and then we could plug in all the points and see if the points are above or below the line. And that's going to be what most answer explanations are going to tell you to do. I personally prefer thinking about this differently, because when the SAT gives these questions, almost always the X values that they give in all of their answer choices are the same. And that's the case here, where we have 2, 4, 6, 2, 4, 6, 2, 4, 6. So what I'm going to do to solve this is I'm going to think to myself, okay, well, we know the values have to be above the line, and we know where the values for 2, 4, and 6 are going to be on this line. We know that at 2, we're at 4 times 2 plus 8, that's 16. At 4, we're at 24, and at 6, we're at 32. And so in order to have a y that's above this line, we need the y's to be greater than 16 for 2, greater than 24 for 4, and greater than 32 for 6. So we just need to pick the table where all 3 of these y coordinates are above all 3 of these y coordinates, which would be answer choice A. And I think that's a little bit faster than plugging everything in. Number 4, we have this linear function, and we're asked for what value of x does f of x equal 5. So basically when f of x is 5, we're trying to solve for the corresponding x value right there. Easiest way to do this is to just put it into Desmos, where we say 5 equals 9 over 7x plus 8 over 7, and we get a vertical line 3 as the answer. Another way of thinking about this is you could have put the function directly into Desmos and then asked Desmos to also find where f of x equals 5. This is a horizontal line at x equals 5. And it's the same idea. We would get the point 3, 5. We're solving for x, so it would be 3. Both of these are totally valid. Number 5, during a portion of the flight, a small airplane's cruising speed varies between 150 miles per hour and 170. So we're somewhere between 150 and 170. Which inequality represents the situation where s is the cruising speed? Well, we know the speed's between 150 and 170, so it's going to be the answer that's between 150 and 170 inclusive. I have nothing else to say about this. It's that simple. This feels like it should be harder. I promise you it's not. That's the answer. Number 6, this graph models the number of active projects the company is working on X months after the end of November 2012. So let's think about what that means. That means that this is November 2012, this is December 2012, this is January 2013. Sure. So what is the predicted number of active projects? What variable is that going to be? Well, we're modeling the active projects X months after November. The thing that we are modeling with a function or with a graph is the y. Right? The y is like your dependent variable, inputting some number of months, and the function outputs or models the active projects. So the projects is y. So when they say, what's the predicted number of active projects? That's asking, what is the y? Solving for y at the end of November 2012, well, the end of November 2012 is x equals 0. So we're solving for the y when x equals 0. That is just your y-intercept, which is 5. Number 7, in the linear function h of 28 equals 15, and h of 26 equals 22, and we're trying to solve for h. So one thing you can do is you can manually find the slope, find the intercept, right? That's all we're doing. You find the slope with your change in y over change in x. If we treat this as like your first point and this is your second point, then your y goes up by 7 and your x goes down by -2, which means your slope is -7/2. So that narrows it down to c and d. And then to solve for the y-intercept, we can simply take our equation and we can plug in one of these points. Let's plug in the point 28, 15. So 15 equals -7/2 28 plus b. That's going to be 15 equals -7 times 14 plus b. And then we can use Desmos to say b is going to be 15 plus 14 times 7, which is going to be probably, it's 113. It's probably not going to be 23. However, I don't recommend you solve it by hand. That's why I was going through that quickly, because that is a valid way to solve. And if you tried solving by hand and got it wrong, you probably made an error somewhere in your algebra. A more reliable way of solving this would be to use Desmos and run a regression. So we can go into Desmos, we can click this plus, click table. And I showed you this earlier in a different section, but this is probably the most powerful and most common use case is this right here, not the weird exponential stuff we were doing before, literally just this. We're trying to come up with the equation of a line. So we know that when x is 28, h is 15. When x is 26, h is 22. So these are our 2 points. And we want to click this add regression button here, run a linear regression. This basically draws a line that connects the 2 points. And the line is told right here, negative 3.5x plus 113, which indeed is the answer we chose. You can even copy this down by pushing this button, and then you can manipulate it. Maybe turn this into f of x. If we wanted to translate, we could translate, do whatever we want with that. Right? This is a very, very powerful tool. You should be comfortable using it. It's going to be more reliable than trying to do all this stuff by hand. Problem number 8, we have the number of cars C and the number of passengers P. And we're asked which equation represents the linear relationship between C and P. So this seems very easy, like just put it into Desmos, find the equation of the line. The problem is that all of these answer choices are in standard form, not slope-intercept form, so we have to do that conversion. But that's not terribly difficult to do. So first, let's find the slope-intercept form equation the same way that we have been before, which is to write the regression. So 174, 284, 559. So this is our table. We add regression, get a linear regression, get an equation. We can paste it down if we want. 55x plus 9. So y equals 55x plus 9. That's p equals 55c plus 9. And now in order to convert it to standard form, we just need to get our both of our variables on the same side. So we subtract 55c from both sides, and we're still not quite there. Notice all of the 55s have a positive coefficient, so we can multiply everything by -1 to get this. And if we swap the 55c and the p, then it looks just like answer choice A. Number 9, which of the following is a solution to the given quadratic equation? So just by looking at the answer choices, you can sort of see that if you wanted to solve this by hand, you would need to use the quadratic formula because you have square roots in your final answer. That tends to be sort of a giveaway that this uses the quadratic formula rather than simple factoring. If you see answer choices that look like this, it's going to be a quadratic formula process. And the quadratic formula is tedious, and we don't want to do that. So I'm going to use Desmos for this. Instead of w's, we'll use x's, x squared, get out of here, Epic Pen, plus 12x minus 40 equals 0, and we get one solution at 2.7178. Now that's not the most helpful, so we're going to want to plug in our different answer choices and sort of see which one, see which one lines up. So it appears that 2 minus this is the negative counterpart, so presumably we want D, which is like the negative version of A, right? Like if you multiplied all of this by -1, that would leave you with this, and likewise our answer choice is flipped. So again, we're solving for this, and then we're just plugging in A, B, C, D until we get the right one, but we were able to do this little shortcut to skip B and C. Problem number 10, what is the y-coordinate of the y-intercept of this graph in the xy plane? So we could try to plug in x equals 0 and then solve for y, or we could rearrange this into slope-intercept form and then identify your b value. But those are both going to be a lot more time-consuming than just plugging it into Desmos. It's already plugged in because I already solved this and then realized my video wasn't recording. So the answer is going to be 37.8. It's just the y-intercept on the graph. It's that simple. Problem number 11 gives you 2 lines on a graph and says what system of linear equations is represented by the lines shown. The problem with this is they're all in standard form, and this makes this a lot more difficult for us. So instinctively, the first thing that comes to mind is they share the same x-intercept of 8, so we can roll out answer choice A. But this is a little tedious if we have to go through 2 equations in all for answer choices, and that alone might not give us the correct answer, right? It's possible that multiple answer choices all have the correct x-intercept. And so then maybe we could use x-intercept and y-intercept. Surely that would get you the answer. The problem is your y-intercepts are pretty awkward, right? Like, what is this? Is this like 3.2? We don't know what the y-intercepts are exactly, so it's very difficult to work with. You could also use the fact that the slope of these lines is negative a over b, and maybe use that to your advantage, where a and b are referring to the coefficients of x and y. The problem with that is this is very time consuming as well. Like, there's no good option. We're gonna need to go through all 8 options and do something to it in order to definitively find the answer. And so if we're doing that anyways, might as well go through all 8 options in Desmos, because Desmos is very hard to make a mistake in. So we see 8x plus 4y equals 32, and then negative 10x minus 4y equals negative 64. This gives us two lines. They're both decreasing, so this looks promising, but we don't see that they have the same x-intercept, so we can rule that out. Answer choice B just flips this into a negative and flips this into a positive, but now they're both increasing. That's problematic. For answer choice C, the first line is increasing, so that's already problematic, and we know that's not going to be correct. And then answer choice D is, by process of elimination, the correct answer, but we can plug both of these in to make sure that's correct. And sure enough, we see that they both share an x-intercept at x equals 8. They're both decreasing, and presumably the y-intercepts are indeed at 3.2 and 6.4, which looks about right. So we can pick answer choice D. Question 12 is another one of these problems where we could put this into Desmos and then solve for the solution to the system, but College Board is begging us to solve this by hand using a shortcut. I say they're begging first because the answer choice is not asking for x or y or the point xy, but it's specifically asking for some weird combination of x's that it very closely resembles the equations that were given. You can also see the College Board is begging us to add both equations together because we see a plus 4 y plus 7 and then a minus 4 y plus 7, and so if we add both of these equations together, they cancel out. And so College Board is basically telling us, like, this is what you're supposed to do, this is what they want you to do. Sure, you can use Desmos, but if you add these two equations together, we get 2 times x minus 2 equals 559. And then if we multiply both sides by 3, you get straight from 2 times x minus 2 to 6 times x minus 2, which gives you 1677 as your final answer. Number 13 asks, what is the minimum value of the given function? So the given function is a quadratic, so the minimum value, specifically the minimum y value, is down here at the vertex. It's basically saying what y value is the vertex at. And the easiest way to find this is going to be in Desmos, literally just plugging in your function and then clicking on the minimum value. An alternative option would be to use the formula h equals negative b over 2a and then solving for that and then plugging it back in. But that's just going to be a lot more time consuming than going into Desmos and clicking on this. We have a very skinny function, Ozempic function, giving us a minimum of 1728, so close. Number 14 asks, how many solutions does the given equation have? So there are a couple ways you can think about this. The first one is you just look at it and you immediately acknowledge, like, oh, the only solution is going to be x equals 0. So there's exactly one solution at x equals 0. Like, when x is 0, you get 0 equals 0. There's no other value you can plug in to where multiplying it by 49 is the same as multiplying it by 98. Like, maybe that just makes intuitive sense to you and that comes to you very quickly, but maybe you want to prove it for yourself. So you can go into Desmos and you can type in the equation, negative 49x equals negative 98x, and we see a single solution at x equals 0. Would you look at that? That's exactly what we thought would happen. But another way of thinking about this is you can break it down into a system of equations where we have the left-hand side as one line and the right-hand side as another line. And sure enough, we see the same exact conclusion, which is that there's one point of intersection at 0, 0. And when you graph the lines like this, or think about the graphs of the lines like this, it should be very clear that there's going to be only one point of intersection, because for two lines to have infinite points of intersection, they need to be the same line, which these are not. And for them to have no points of intersection, they need to be parallel, which they are not, because the slopes are different. We can also rule out like 2 or 3 or 4 points of intersection, because these are lines, and lines can't do that. That's not how lines work. So our answer choice will be exactly one solution. Problem number 15, the function g is defined by this, and the value of g of 7 minus w is 0, where w is a constant. So basically this is saying that when we plug in g of 7 minus 0, or 7 minus w, that gives you 0, which means 0 equals 7 minus w times 7 minus w minus 2 times 7 minus w plus 6 squared. And I'm going to write this a little bit nicer, where 7 minus w minus 2 we can replace with 5 minus w, and then 7 minus w plus 6 squared we can replace with 13 minus w squared. So really this is what we're working with. It's a single variable equation where our single variable is w, and we're trying to find the sum of all possible values of w, which is the same as the sum of the solutions to this equation. So we solve this exactly how you think we would. We take this equation, we put it into Desmos using x instead of w, and then we look for the vertical lines. Desmos is being weird where the vertical lines aren't giving us answers, so we do what we want to do, which is break it down into a y equals the right-hand side and a y equals the left-hand side. In this case, the left-hand side is just 0, so we're just looking for when the right-hand side, which is this polynomial function here, touches the x-intercept, which is at 5 and at 7, and Ooh, would you look at that? Also at 13. So we got to make sure to zoom out enough. The sum of these solutions is really what we're solving for. So we want 5 plus 7 plus 13, which should be 25. Number 16, this is a word problem and I don't like words. So I'm going to start at the very end and use the question that is actually being asked to sort of pry my brain to pick out the relevant information from the rest of the paragraph. So what is the probability of selecting a maple tree? So we want probability of a maple tree given that the tree is 20 feet or taller. So a nice way of understanding conditional probability is that your given is like the group that you are sampling from. And the maple trees is the group that we're actually looking for. So what we really want is basically a fraction of maple trees over tall trees. I'm just going to call the trees that are 20 feet or taller tall trees, and the trees that are less than 20 feet short trees, because that's fewer numbers to have to juggle in my head. So we're basically saying, conditioned on all tall trees, how many maple trees are there? Knowing that this is what the question is asking for is going to make it a lot easier to read the paragraph and like parse through the information, especially if the information is given to us in a really complicated way, which it looks to be. There are a lot of numbers here. Maybe some of these numbers aren't relevant. Maybe they are all relevant and it's just a lot to juggle. So it's going to be very helpful to be able to read this paragraph knowing what the end goal is before we actually start reading it. So now let's read the actual paragraph. A grove has 6 rows of birch trees and 5 rows of maple trees. Each row of birch trees has 8 trees 20 feet or taller. So I'm going to say 8 tall trees and 6 trees that are shorter. We know that we're only conditioning on tall trees, which means we can completely ignore all the short trees. They're not relevant to the problem. What we care about is how many tall trees there are and how many of those tall trees are maple. And so this piece of information is relevant to us, that each row of birch trees has 8 trees that are tall. And there are 6 rows of birch trees. So if each row has 8 tall trees and there are 6 of them, we would do for tall birch, we would do 6 times 8, which is 48. There are 48 tall birch trees in the entire forest, or the entire grove. I don't know what a grove is. This is why I'm not an English tutor. So then we see that each row of maple trees has 9 trees that are 20 feet or taller. So again, there are 5 rows of maple trees, 9 trees per row. That would be 9 times 5, so 45 for the number of tall maple trees. And so we can say that the total number of tall trees is going to be these two numbers added together, which gives you 93. So if there are 93 tall trees and 45 of them are maple trees, then we have a 45 out of 93 probability of selecting a maple tree if we're randomly picking a tall tree. That's what this problem is getting at. And we were able to better parse the paragraph and figure out what information was relevant because we first looked at the question and sort of got an idea of what we're actually solving for. However, you might notice none of these answer choices are 45 over 93. That's because fractions on the SAT are always presented in simplest form, and this is not simplest form. We can divide both the numerator and the denominator by 3 to get 15 over 31. That's going to be your simplest form fraction. There's your answer. Problem number 17, a rectangle is inscribed in a circle. So that basically means we have a circle and then we have a rectangle such that the vertices or corners of the rectangle are touching the edge of the circle. That's what the word inscribed means. And they actually describe that for us in the next part of the sentence. The diagonal of the rectangle, so this, is twice the length of the shortest side of the rectangle. So let's say this and this are the shortest side, let's call that x, and the diagonal is twice the length of that, so the diagonal would be 2x. The area of the rectangle is 1089 rad 3. So we know that the area is the length times the width, which in this case we can call this side the length, and then x would refer to the width. So the area of 1089 rad 3 is equal to the length times x. What is the length of the diameter of the circle? So what I hope you notice is that the diameter is this 2x. It is the diagonal of the circle. And so really this is just asking us to solve for 2x. A good way of thinking about this is that the number of variables that you can solve for has to be equal to the number of equations you have. So if we're trying to solve for 2 variables, you need 2 equations in order to solve for them. So we need a second equation, and what should hopefully come to mind is the Pythagorean theorem, because we have a right triangle and we know all 3 sides of the right triangle, which and the Pythagorean theorem is just a way of comparing these 3 sides. So we know that x squared plus L squared equals 2x squared. This means x squared plus L squared equals 4x squared. That means L equals the square root of 3x squared, which is the same as x rad 3. You might have also recognized that this is a special right triangle, and if you recognize this, great. You are saving yourself a lot of time, because this is a 30, 60, 90 triangle. The fact that this side is 2x and this side is x means that the other side has to be x rad 3. Like, it's inevitable based on these two sides that that's going to be the third side. And so we technically didn't need to do the Pythagorean theorem. If you acknowledge that this was a 30, 60, 90 triangle, then you could just say, okay, this means that the long side has to be x rad 3. And so now that we're here, we can replace this L with x rad 3. This means 1089 rad 3 equals x squared rad 3. That means 1089 equals x squared. And so I can solve for x by doing sqrt 1089 and getting exactly 33. So x equals 33. Is that the correct answer though? We're not solving for x, we're solving for the length of the diameter. What? The diameter is 2x. The diameter is not x, so we want to multiply this by 2 and put 66 in our answer choice. And I deliberately did this so that I can illustrate that there's a lot of value in when you put in your answer choice, just glance back at the thing you're solving for. Just go from your answer to the thing you're solving for, back to your answer. Just a quick double take. I see so many students that are strong in math getting the answer wrong just because they solve for the wrong thing. And it's so upsetting and demoralizing when you get an answer wrong just because you didn't do this quick 5-second double take. And so do it for every single problem. Do the quick 5-second double take. Make sure you're solving for the right thing. It'll cost you an extra 2 minutes on the entire test, most likely, and it'll probably save you 1 or 2 questions. Question number 18, the positive number a is, so a is, we can write that as a equals 2,241% of, so 2241, we can convert this from a percentage into a decimal by moving the decimal place 2 spots over, so it's 22.41 times the sum of the positive numbers b and c, so times b plus c, and so new equation b is, so b equals 83%, so 0.83, of C, so times C. We're being very deliberate translating English into math, going piece by piece. B is equals 0.83, 83% of times C. Like bar for bar, we are making sure that without error, we're writing these equations correctly. And then we're asked what percent of B is A. So this is a bit more confusing because is here. So is A means equals A, what percent of B? So we have some percentage times B. And I'm writing P over 100 because we want to treat the percentage as a decimal, but we are ultimately solving for the percentage P. We're not solving for the decimal version of that percentage. If you'd rather treat this as a decimal and then convert it at the very end, you can totally do that. But to be super formulaic about this, anytime I see what percent, I'm going to write P over 100. And so I think a lot of people are going to see this and have the wrong idea, where they're trying to actually solve for A, B, and C. But this is not possible. And we know it's not possible for the same reason we were talking about before. Here we have 4 unknowns and 3 equations, which means we're not actually going to be able to get concrete values for A, B, C, and P. We're trying to solve for P, but we can do that by rearranging these 2 equations in this form. For example, if we somehow rearrange these 2 equations to be A equals 0.5B, then we would say the answer is 50%. Right? So that's the goal. That's what we're trying to do. Let's think about how we get there. So we want to keep A on its own, and we have that over there, but clearly we don't want C's. So I'm going to rearrange this so that we can solve for C. C equals B over 0.83. And then I'm going to substitute that in to this first equation. So A equals 22.41 times B plus B over 0.83. So this is the right idea, right? We have an A equals and then a bunch of other stuff with only B's. But we need a single coefficient times B rather than the mess that we have here. So I'm going to think about this as factoring out the B and factoring in the 22.41. So we get B times 22.41 plus 22.41 over 0.83. Then I'm going to use Desmos to figure out what that actually is. We get 22.41 plus 22.41 over 0.83. That equals 49.41. So we get 49.41B. Now, if you're impatient, you're going to pick B as your answer choice and roll with it. But let's be very cautious here. Remember, this is a decimal. We're solving for what percent of B is A. Do a little double take, make sure you're solving for the right thing, and you'll realize that the answer choice is actually D, because the decimal If we want to convert the decimal into a percentage, you do the opposite of what we did before, move the decimal place 2 points over, or you can think of it as multiplying by 100, because this p is going to be 100 times larger than its decimal counterpart. So D would be the correct answer. Question number 19. Now we're done with all the fake baby problems. We're getting to the real problems. In a given system of equations, p is a constant. If the system has no solution, what is the value of p? So the first thing we want to do is identify that this system of equations is a system of linear equations, which is not told to us, but we know because the x's are all to the first power, and so are the y's. If you had x squared, for example, that would be quadratic or cubic or quartic or exponential or rational, but this is just like straight up x. So when you have a system of linear equations with no solution, that means the two equations are completely parallel. And so one thing that we can do is we can put these equations into Desmos and then move your p slider to see when these two lines are parallel, or what value of p would make these two lines parallel. That's probably going to be the most accurate approach. So let's go ahead and do that. We put both equations into Desmos as is, then we add a slider for p, and then we can move p around until they're perfectly parallel, which would be at p equals 3.5. But 3.5 is a little suspicious. Like, do we really know if they're parallel? And what if we were in a situation where instead of p equals 3.5, this were like p equals 4/3? And we're not going to guess that it would be 1.33333 repeating. Like, it's going to be very, very difficult to get certain fractions that they could give us. So in the case that this p were not decisive, we would need to convert both equations into slope-intercept form by hand, and then compare their slopes to see when the slopes are the same, because two lines with the same slopes are completely parallel. However, Desmos in this case gave us a pretty concrete answer. It's going to be 3.5, and we can type this in as a decimal or as a fraction. It's up to you. Number 20, now we're getting into the real problems. I know I said that for number 19. Number 19 was a fake problem. That wasn't a real, but this one's a real problem. So number 20, we have a bunch of values for g of x equals f of x over x plus 3. This is a little weird because we know what g of x is, and we don't know what f of x is. So I'm going to rewrite this. F of x equals x plus 3 times g of x. This makes a little more sense given the fact that our table only gives us one of these functions. And we're told that f is a linear function. G is not a linear function, but f is indeed linear. What is the y-intercept of f of x? So we need to know f of x, and then we need to use f of x to figure out the y-intercept. And so this is a really weird setup that we're given, but if we have 2 points that we know f of x is on, then we can find the equation for f of x, right? Like, this is just, we've done this before. We create a regression in Desmos, we find the equation of the line. So really, we just need 2 points that we know are on f of x. And we have an equation and a table that we can combine to figure out what those 2 points are. So let's start with the first row for x equals negative 27. F of negative 27 is negative 27 plus 3, that's negative 24, times g of negative 27, which is right here in the table, 3. So that gives us negative 72. Then for the next point, we can use the second row on the table. We're going to multiply by g of x, which for the second row is 0. So this just gives us 0. And we could do the same for the third row, but we don't care because we already have our 2 points. Simply go into Desmos, add a table, and then negative 9 gives us an f of x of 0. And so now we have these 2 points, and we can find the line that connects them by going to add regression, linear regression, 4x plus 36. This means the y-intercept is 36. That would be answer choice A. Okay guys, remember when I said number 20 was a real problem? I lied. Number 20 was a fake problem. Now we're getting at the real problems. The SAT hates us, so they're going to describe the circle instead of just drawing us the circle, which would actually be very, very easy for them to do. They just didn't feel like it. So we have a circle with center G, and we have points M and N that lie somewhere on this circle. Then we're told that line segments MH and NH are tangent to the circle at points M and N. So to be tangent at point M and to be tangent at point N means that you have these radii that connect G to M and G to N, and when the line tangent to them makes a 90-degree angle with the radius. So my drawing is absolutely excellent. And then they go all the way over to this point H over here. We know that H has to be over here instead of over here, because if MH were to be over here, how would NH ever get there? And so this is the setup that we have I'm sure you can tell I'm an artist. If the radius of the circle is 168 millimeters, so 168, and the perimeter of this quadrilateral GGMHN is 3856, what is the distance between points G and H? So the thing we are ultimately solving for is this distance in blue between point G and point H. So you might be thinking, okay, well, presumably this has to do with the Pythagorean theorem, right? This blue line is the hypotenuse of this right triangle and also the hypotenuse of this right triangle. The problem is, even though we know the radii is 168 and 168, we don't know what this length and this length is. That is where the perimeter comes in handy, because these two lines have to have the same exact measurement. MH and NH have to have the same exact measurement. And you might think, well, how do you know? Well, one way is you can just memorize the fact that if you have two tangent lines, they're going to meet up at this point, and those two tangent lines have the same length. You can also like intuitively understand it just by looking at it, and like it sort of makes sense that this blue line is like an axis of symmetry. It's sort of taking your Christmas tree. This looks like a Christmas tree to me, okay? Like this is the base, and then this is you got the ornaments and stuff. So it's a sideways Christmas tree. It cuts the sideways Christmas tree in half. It sort of makes sense that those sides should be the same. But the more mathematical way of being able to prove this concretely is that the blue line is the same hypotenuse for both triangles. So if your A is the same and your C is the same, then your B also has to be the same. There's no way that A squared plus B squared equals C squared for both of these triangles, and they have the same A and the C but not the same B. So with that being said, let's call this side X and let's call this side another X. We get 168 times 2, because there are two 168s, plus 2X equals the entire perimeter, 3856. And if we're too lazy to solve this by hand, we can use Desmos in order to solve for X. We have to zoom out a bunch, but eventually we get X equals 1760. And so now I'm going to pick C as our answer, and we're done, is what I would say if I were stupid and I were failing the SAT. Because this is not the thing we're solving for. We are solving for the distance between points G and H. So what we want to do is find this hypotenuse. And you can find the hypotenuse by doing the Pythagorean theorem. 1760 squared plus 168 squared equals this hypotenuse. I'm going to call it D for distance squared. And I'm going to do this all in my head and pick answer choice D. I'm kidding. I didn't do that in my head, but I know it's going to be answer choice D because the hypotenuse has to be longer than the side lengths, right? And the only answer choice that is longer than 1760 is 1768. Finally, we are on to number 22. Remember when I said number 21 was a real problem? That problem was easy. That was a fake problem. This is a real problem. This one, let's just say this is a real problem. So number 22, we have a quadratic function, and we're told the function f of x passes through these 2 points. So just to sort of think about what this looks like visually, let's have an extremely accurate artist's rendition. It touches x equals 7 and x equals -3, just like that. If a is an integer greater than 1, an integer just means a whole number. So like 1, 2, 3, 4, those are going to be our integers. Integers can also be negative, but in this specific case, we're told it's an integer greater than 1, and we're also told strictly greater, so it actually can't be 1. It's got to be 2, 3, 4, or something else. And when they tell you something about the a value, that is 100% relevant, and we're going to see why in a second. So the ultimate thing we're trying to solve for is what could be the value of a plus b. Notice this word could. When they tell you the word could on the SAT, it means there is a range of acceptable values. We are not solving for a plus b, we are solving for one of many possible values of a plus b given the information that we're handed. And when you're solving for a range of values, that means we're probably not working with an equation, but rather an inequality. It seems like the inequality they just gave us, might come in handy somewhere. But the inequality is clearly not like giving us a plus b quite yet. We have to do something else. And the only other piece of information that we're given is this. We're told the x-intercepts, or the solutions to the quadratic. That might not seem very helpful, but it is helpful if you write the function in factored form. So the factored form version of a function takes your scale factor a and multiplies it by your factors. So we have x plus 3 and x minus 7 as our two factors. The idea being, if we plugged in -3, we would get 0. If we plugged in 7, we would get 0. It checks out. So how does this help you find a plus b? Well, we need to convert this factored form that we're given into the ax squared plus bx plus c form that we actually want to be able to use. So we do FOIL, get x squared plus 3x minus 7x minus 21. That's a times x squared minus 4x minus 21. And we still need to distribute this a to really get us into this form. So we get ax squared minus 4ax minus 21a. Why did we do all this? Because now we can clearly identify our a is equal to a. Didn't see that one coming. Our b is equal to negative 4a. That part's relevant. And our c is equal to negative 21a, but we don't care about that at all because we're only solving for a plus b. If we were solving for a plus b plus c, you would need to care about your c. But in this case, we're solving for what could be the value of a plus b. So a plus b, that's the same as a minus 4a. That's the same as negative 3a. So really what we care about is finding an inequality involving negative 3a, basically looking for the range of values that negative 3a could be. And now we can use this inequality to our advantage. A has to be greater than 1. That means 3a has to be greater than 3. That means negative 3a has to be less than negative 3. Notice we are flipping the inequality symbol. That's because we're multiplying by a negative. And if you don't really understand why you have to flip the sign, think of a very simple example. X is greater than 0. That means that x is a positive number, right? If we wanted to convert this to negative x, and we said negative x were greater than 0, well, that makes no sense, right? Like negative x is by definition a negative positive number, which is a negative number. Why would that be greater than 0? Surely we should flip the sign and make it less than 0. So this example should hopefully illustrate why you have to flip the inequality sign. But by this point, you should have that memorized and just like do it instinctively when you're doing algebra. So we get negative 3a has to be less than negative 3, which as we recall is the same as a plus b. So a plus b has to be less than negative 3, and only one of these answer choices is less than negative 3. So lots of stuff going on here. I also want to mention that you technically could have approached this in vertex form. You can say that the x-coordinate of the vertex, the h value, is the midpoint of 7 and negative 3, which is going to be 2. And then you can write this as a times x minus 2 squared plus k, and then you basically ignore your k, expand it all out, and you're going to get the same thing. But I think factored form is a much more straightforward way of looking at it, given that you're literally given your factors. And so no matter how you approach it, though, there's a lot of stuff going on in this problem. There's a lot of stuff to take note of. Quadratics problems are hard, and this is the hardest type of quadratics problem you're going to see on the SAT. But at the end of the day, this is a standardized test, which means you're going to see the same patterns over and over and over again. Patterns meaning the word could, indicating that the answer, your final answer, is going to be an inequality. That is a pattern that you can like internalize by doing multiple of these problems. The fact that your solutions give you factored form of a quadratic, that is a pattern that you can internalize. And so what I recommend you do for complicated problems like this is first try teaching yourself the problem. If you can teach it to yourself, like walk through the problem just like I did, talking out loud through every single step, then you really do know whether you understand it or not. And anything that you're struggling to explain, that's something you should double down and focus on and really understand deeper. And then the second step after you teach it to yourself is to create a variation. Creating variations of the problems is incredibly helpful for just like practicing the same patterns over and over and over again. So the simplest thing you can do with a variation is just change up the numbers. Replace 7 with 17, replace negative 3 with negative 10, and see what happens. Maybe make a less than 1 instead of greater than 1. A more complicated variation would be change the thing that you're solving for. So maybe instead of solving for a plus b, solve for a plus b plus c. And I believe with these numbers that should be solvable. Another thing you can do with your variations is change up the information that you're given. So instead of being given the solutions, maybe you're given the x-coordinate of the vertex. Let's say the x-coordinate of the vertex is negative 4. How would you solve the problem if that were the case? So there are a lot of different variations that you can make, and that's sort of the best way to get a lot of value out of a single problem that you miss. And it also gets you thinking about the right things. And so I hope you found this video helpful. If you're trying to solve real difficult problems like this in a very structured, formulaic way, check out my SAT Math Masterclass. I promise it's worth it. And regardless, good luck studying.